Welcome to this explainer. Today we're diving into the silent night, Earth without a moon. We are going to strip away literally the most familiar sight in our night sky, and what we find is going to reveal the hidden architecture of our entire planet. Let's get right into it.
So I want you to imagine stepping outside tonight. You look up, the sky is still there, it's still vast, but it's missing that one object that has shaped human life for as long as our species has existed. No bright silver disk, absolutely no moonlight. What if Earth just had no moon? What if it never formed, or, just vanished? Now, this isn't just some fun cosmic fantasy. It's the start of a profound chain reaction of consequences. We're talking about everything from the deep oceans to the climate to our very sense of time itself. Without it, Earth becomes a wildly different planet.
Okay, let's dive into this. The very first, most obvious change, the night sky itself. We go from our current night, bathed in that familiar, comforting silver glow we're so used to a moonless night that is pitch black. It's quieter, and it is vastly more uncertain. This immediate loss of moonlight fundamentally rewrites the environment because, honestly, darkness matters far more than most of us realize.
Think about it. Millions of years of animal evolution have relied entirely on lunar cycles. Animals use the moonlight for their hunting patterns. They use it for plotting massive migration routes, timing their nesting behaviors, their breeding cycles, and, crucially, for predator avoidance. For instance, without moonlight, predators like owls lose a massive hunting advantage, and creatures like baby sea turtles, they literally wouldn't know which way the ocean is. Without the moon, the habits of countless species are thrown into complete darkness. The night would belong fully to the dark, forcing a massive, chaotic biological adaptation.
Now, let's shift our focus from the sky to the oceans, because this is where some of the most dramatic physical changes would occur. The moon is the absolute dominant driver of our tides. We'd go from this strong, dynamic tidal pulse to significantly weakened tides. Now, the oceans would still have some tides, right, because the sun exerts a gravitational pull too, but they would be drastically reduced in their range. Basically, they'd be a fraction of their current strength.
And here's why that weakened pulse is such a big deal. A calmer, less pulsing ocean forces the entire marine environment to adapt to completely new, less dynamic conditions. We are talking about massive, disruptive changes to intertidal zones where the land and sea meet. It transforms estuaries, salt marshes, entirely alters coastal fisheries, and causes a huge shift in global nutrient circulation. Shorelines would sit differently. Sediments would move differently. Ocean life wouldn't just disappear, but it would be forced to evolve under a totally different set of rules.
But the effects go so much deeper than just water. The moon acts as this crucial gravitational anchor for Earth. By this, I mean the moon's mass actually prevents our planet's axis from chaotic wobbling caused by the gravitational pulls of other planets in our solar system. Its absence, it literally threatens the very stability of our planet's tilt.
Let's walk through how this builds, because this loss of an anchor triggers a devastating geological chain reaction. Step 1, the anchor is missing. Step 2, over long periods of geological time, our planetary axis becomes chaotic. It starts wobbling. That leads to Step 3, extreme climactic swings. And finally, Step 4, highly unpredictable seasons. Without our lunar anchor, instead of the nice, relatively stable tilt we enjoy now, Earth becomes far, far more vulnerable to violent climate shifts over millions of years, the kind of shifts that could severely challenge the survival of life itself.
And speaking of deep time, our planet's spin history would look incredibly different. Early Earth might have retained a much more chaotic, rapid rotation. You see, over millions of years, the moon has been gradually slowing Earth's rotation through tidal friction. Without the moon, that slowing process weakens significantly. Fast forward to the present day, and we would have a completely altered day length. And since day length affects how storms behave and how heat moves around the globe, this would drastically change long-term weather patterns and the internal rhythms of literally all biological life.
So the really crucial point here is how this physical history connects directly back to biology. Some scientists theorize that the early moon may have driven those vital tidal cycles that helped mix shallow waters, chemicals, and nutrients. This constant chemical mixing, it could have been absolutely essential to organizing early life. The moon is deeply woven into the background conditions that helped life flourish. You remove it, and the very foundation of Earth's biological history changes entirely.
Which brings us to just a staggering question. Would Earth have even become habitable without the moon? It elevates the stakes completely. We aren't just asking what happens if the moon disappears today. We're looking at whether the moon might have been a strict prerequisite for Earth becoming a stable cradle of life in the first place.
But
Let's say we assume humanity still emerged and evolved anyway. We have to look at how our culture would change. Take the concept of a month. It's a measure of time historically derived from tracking lunar cycles. I mean, it's literally a month. Even the word Monday is just a translation of Moon's Day. Ancient societies tracked this long before we had clocks or satellites. Our very concept of time is intrinsically tethered to this single glowing rock hanging in our night sky.
Look at how vastly different human civilization would be. A lunar-influenced culture gave us moon-based calendars, early navigation across the oceans, and just countless myths and religious rituals. Without it, we'd be a purely solar-reliant culture. We'd have the strict, sole dependence on the sun and seasons, leading to completely altered agricultural planning. Our language, our poetry, our imagination, they would have fewer lunar references, meaning human culture as we know it would have been fundamentally reorganized from the ground up.
And this brilliantly illustrates a really fun irony. For science, earthbound astronomy would actually be easier. Backyard stargazers and professional astronomers alike would absolutely rejoice at having consistently dark, pristine nights without a full moon washing out the view. But on the flip side, human space exploration might have been significantly slower. Think about it. The moon was our nearby laboratory. Without that visible off-world destination right there to inspire us and act as a stepping stone, our great push into space might have taken a completely different route. Or maybe it would have stalled entirely. Then there's the profound emotional impact. A moonless night might feel more alien, more raw, and purely starlit. The moon gives us a sense of comfort, a feeling that we aren't totally isolated out there in the dark. It's associated with romance, calm, and cycles. Without it, the emotional vocabulary of the sky would just be weaker. The heavens would inspire this sort of cold cosmic awe rather than an intimate connection. The sky would simply feel far more distant. As the source text for this explainer so beautifully puts it, the moon has watched over every civilization, every empire. It has been a witness to everything. It's watched every ocean crossing, every goodbye, every war, and every harvest. The moon isn't just a rock. It's an integral, irreplaceable part of our collective emotional memory as a species. Ultimately, without the moon, Earth would still be beautiful, but the beauty would be lonelier. That's a core philosophical takeaway here. The moon makes our planet feel more alive, more rhythmic, and more deeply connected to the rest of the universe. It is definitely not just a decoration. It is a load-bearing pillar in the invisible architecture of our world.
Which leads us with this final, incredibly provocative thought. Are the things we take for granted in the sky the very conditions that made us possible? A seemingly small change in cosmic architecture can shape life on an enormous scale. It's the kind of thought that really forces us to marvel at the incredibly delicate, interconnected web of our cosmic ecosystem. So next time you step outside at night, take a real moment to look up at that silver disk. Thank you for diving into this explainer with me, and keep exploring the incredible architecture of our universe.